Alright, welcome back to the last part of this very long lecture. Now, we've been talking about different kinds of weather systems all throughout this, and at least trying to get some basic framework for understanding them so that we can drop words like hurricane and cyclone in the class and we at least know what we're talking about. And for one last weather pattern that we're going to be talking about today, we're going to talk about monsoons. And I don't know if you know, but that's actually what I do. My research is about monsoon meteorology, and in particular about West African monsoons, and man, I could talk your ear off. I could literally teach a whole course about this. This is exciting stuff to me, but we just want to kind of get a broad overview here of what it's all about when we talk about monsoons and what the winds are doing and so on. Now, if I just wanted to pull out a dictionary definition of what the word monsoon means, a monsoon is supposedly a reversal of the wind direction at the surface, usually accompanied by a change in the precipitation regime that occurs in the tropics on a seasonal timescale. Oh my goodness, that definition has got lots of little pieces that are important. First off, this idea of the reversal of the wind direction on a seasonal timescale. Okay, let's take the first and the end of this here. So we're saying that like for half the year the wind tends to be from one direction, and now we're going to reverse the wind and go for the other half of the year from the other direction. Right off the bat, that should seem like something that we do not see when we're talking about, say, the weather of the Midwest. In the Midwest, the winds tend to just come from every different direction depending on what's going on in the weather. Behind a cold front, the wind is more from the north. Behind a warm front, the wind is more from the south. The directions might be more from the east or more from the west depending on the passage of a mid-latitude cyclone and so on. But that's not really the way it works in a monsoon region. In the monsoon region, they tend to have very persistent winds, generally from the east, that become more from the west during the summer, during the half of the year that is the warmer half of, well, it isn't necessarily warmer, but that would be the summer in that hemisphere, let's put it that way. These are the tropics. They don't tend to have a whole lot of difference between the wintertime and the summertime temperature. Notice that it says that it is generally accompanied by a change in the precipitation regime. That means that's jargon that means basically there's a wet season and a dry season. And in general, the wet season is going to be the summer. And it only happens in the tropics. This kind of weather pattern does not happen, in the mid-latitudes or in the polar regions or something like that. So let me just sort of... It pains me not to give you lots of information, lots of details about how all this works. But let me at least kind of give you a couple quick examples of what I mean by a monsoon. And we're going to turn first to my beloved West Africa. Here's a globe here. West Africa is that sort of bulge of Africa that pokes out into the Atlantic Ocean over there. And in case you're not familiar with the geography. And so here's a kind of a physical map of West Africa, which I didn't notice until just now is labeled in German. Okay, that's no problem. Das ist gut. We can do that. Anyway, you know where we're talking about here. The West Africa here. And the winds in, say, January are, well, they kind of look like trade winds. Trade winds are those persistent tropical winds at the surface that have an easterly component. Remember, we described winds in terms of the direction they're coming from. So these are kind of easterly, northeasterly winds, and they're very persistent, okay? They're not having a bunch of cyclones and anticyclones passing through, changing the wind direction. This is a very persistent feature of the atmosphere. So really, not just, we're north of the equator, so we can call January winter. And in the winter, most of the sub-Saharan Africa, that is like south of the Sahara, is going to see these persistent northeast winds. The right word for these particular winds is the harmattan winds. You don't need to know that particular word, but it pained me not to tell you that that's what those are called. But they're kind of related. They're kind of the same sort of thing as the trade winds, which is an important vocabulary word in this class. And, well, if you think about the geography of that part of the world, that means that these winds are coming off of the Sahara Desert. Now, the Sahara Desert in the winter is not a particularly warm place, but it is still a very dry place. So these winds are going to be coming off of the Sahara Desert. They are going to be very dry, very dusty. They have a lot of fascinating properties that we're not going to go into right now. Please take my tropical meteorology class to learn all about the winds in the winter across West Africa. But you can see the winds are going to be basically from the northeast. What's going to happen is in July, we're going to reverse the flow near the surface of the Earth, and we're going to get winds that are principally out of the southwest, which is a very weird thing for a tropical location. We don't get a lot of westerly components to the flow in the tropics in general. There are there are exceptions. Take my tropical meteorology class and learn all about them. But this is kind of a weird thing. I mean, the flow has reversed. It's actually now out of the southwest across all of this parts of West Africa here. Now, you may not know, the Sahara Desert doesn't go all the way to the coast. Down near the coast, it's jungles and grasslands and things like that. And this is the time of year when that area is getting all its rain. This is summer in that part of the world. It's north of the equator, so we can call July summer. And it's going to be seeing these persistent southwesterly flow. And the right word for that is the monsoon flow. Okay, it's going to be the flow coming up during the monsoon, although both the winter and the summer are called monsoons. It's a bit confusing how the terminology works there. But this flow out of the southwest is the monsoon flow. And you see that the flow is coming right off of the tropical Atlantic Ocean. It's going to be warm, it's going to be very humid, and this brings water vapor, this transports water vapor from the ocean over land where it gets converted into precipitation. So this is going to be the rainy season in places like Ghana, Togo, Ivory Coast, Benin, Nigeria, all up and down the west coast of West Africa. This is the time of year where they're getting all their precipitation. We could do the same kind of basic analysis of, say, India. I mean, my guess is before we started this lecture, if I had mentioned the word monsoon, probably monsoons and India was where you were thinking about. Actually, there's monsoons in lots of parts of the tropical world. There's an Australian monsoon, there's a Somalia monsoon, etc. But let's just do West Africa and India. So if I sort of look in India, well, India's north of the equator, so we can call January winter. And during winter time in India, the winds are generally from the northeast. They're a type of trade wind. They're very persistent, and if you look at where they're coming from, they're kind of coming off of the Tibetan Plateau, which is very high and very dry, or even off of, like, let's say Siberia, the vast inland of Russia. And there's not really a lot of source of water vapor in that part of the world. So this flow, which is reaching way down into very tropical places of India, is actually very dry. And so in the winter season, it's the dry season in India. They get very little precipitation. There's just very little water vapor for the atmosphere to work with in India in times of year like January. But if you switch over to July, this is a monsoon climate, so the winds at the surface are going to reverse. We're going to have, once again, southwesterly flow. And so in the summertime in India, that's when we're going to see these persistent southwest winds. And wow, take my tropical meteorology. We'll show some slides in that class that show just how persistent the winds are. They have very little variation from day to day across India during the monsoon. The right word for this flow, this is the monsoon southwesterlies. I don't think I would quiz you on that. The right word for this phenomenon is the southwest monsoon, which is a confusing term for a lot of people because they think the southwest monsoon must have something to do with the American Southwest, like Arizona and New Mexico, which also sort of has a monsoon, but that's a whole confusing thing with the naming of that, okay? So we're not going to go down that path. But you can see the flow is coming across thousands of kilometers of Indian Ocean before it makes landfall. By the time these air parcels reach India, they're very warm and very moist. They're carrying enormous amounts of water vapor onto the Indian continent, where it can be converted into precipitation. So July is the rainy season in India. Now there's a lot of meteorology as to exactly when it starts and how far north it goes and all this kind of stuff. But the basic idea that that should be the rainy season is a good one to know about. Obviously, from the point of view of agriculture and water security and things like that, the rain is what people care about when we're talking about monsoons. We want to know about how much water is available, how much is stored, the hydrology of it, how much is kept behind dams, how much is stored in cisterns, etc. But that's not what we're going to be doing in a wind energy class. In a wind energy class, what we care about is this reversal of the winds. And these winds are pretty strong and pretty persistent as surface winds go. Both the summertime flow and the wintertime flow in any monsoon region would actually be potentially an excellent source of renewable green energy in parts of the world with these developing economies. This is actually a fruitful idea that we should be able to get places like West Africa and Northern Australia. Well, Northern Australia is obviously less developing, so much is developed, but you know what I'm saying. Southeast Asia and so on, as having a lot of their wind power provided, a lot of their energy needs provided by wind power. which makes us think that we probably ought to understand in a wind energy class why monsoons happen. And your textbook. Your textbook makes I was going to say they make an attempt. They make a pretty lame attempt to try to explain why monsoons happen. And I realize that I'm a bit of a monsoon guy. To me, it was never going to work. But basically, the only sentence they give in there is they say the monsoons are caused by a very large sea breeze formed by the difference in heating between the Indian Ocean and the Indian subcontinent. Oh, that does not make me happy. That is not a very good explanation whatsoever as to why monsoons happen. Now, as it happens in the particular sentence where they were explaining this, the author was talking about the Indian monsoon. Well, just because I happen to have more slides available about the basics of a monsoon for West Africa, let's cross out the Indian Ocean and put Atlantic, and let's put across Indian subcontinent and take out that and put in Sahara Desert instead. Okay, so that we're talking about the same expression that the author used, but now we're discussing it in West Africa. Now, he's trying to tell you that this is about a very large sea breeze. And sea breeze is a term that we haven't yet done in this class. In fact, sea breeze comes up, I think it's in the 5th module of the class. But we'll talk about it in more details, but just to kind of give you an idea, a sea breeze is a thing. A sea breeze is a wind that happens during the day, and sea breeze, it comes from the sea. Remember, we always describe winds in terms of where they're coming from. And so, like in this little diagram here that I took from the Comet Program's website, you can see that there's an arrow there that's showing this sea breeze at the surface flowing from the ocean to the land. It's a thing. We are interested in sea breezes. But sea breezes are actually not very much like monsoons at all. I mean, like, for example, sea breezes are mesoscale phenomena. I've got a satellite picture here showing clouds. This little line of clouds that you see along that coastline, that is like the leading edge of the sea breeze as it pushes inland at that particular day. And this map here, this is just a zoom in of central Florida. You can see Lake Okeechobee in the picture and so on. I mean, that sea breeze is charming, but it's, maybe penetrating 10 miles in, and it's maybe 50 miles wide on this particular day. I mean, this is a mesoscale phenomenon. The other thing that makes this mesoscale is sea breezes only last a few hours. In fact, that's kind of part of the definition of what we're going to see in the 5th module makes a sea breeze. I mean, a sea breeze ends at the end of the daylight hours and becomes a land breeze at night, blowing from the land towards the ocean. Well, no, that's not monsoons at all. Monsoons persist for months. The wind is going to be blowing from the southwest, from the Atlantic Ocean into West Africa from like April through October. It's not going to be reverse. It's not only going in a few miles, and it's not only going in for a few hours. The monsoon flow extends thousands of kilometers, well, certainly hundreds, if not thousands of kilometers inland, and it lasts for months. This is kind of different. That being said, there are some ways in which the statement that the author gave in your textbook is not entirely wrong. In fact, I thought of 2 ways in which he was kind of on the right track. For example, monsoons are a bit like the sea breeze in that when it's warm, the flow is from the sea towards the land. I mean, in the sea breeze's case, what they mean is during daylight hours. When the land warms up during the day, the wind flows from the ocean towards the land. And in the case of the monsoon, during the summer, when the deserts of the Sahara get really hot compared to the ocean around it, the flow goes from the ocean to the land. So, I mean, in that sense, it's a little bit superficial, but I get it. It's kind of the same. The author's not altogether wrong in that regard. And as I kind of alluded to, another way in which the author's not entirely wrong about this, it is part of the story about why sea breezes happen and why monsoons happen. It has to do with the fact that the land is heating up. The beach and the area just inland from the beach does warm up more than the water or the ocean does during the day. The sand at the beach is hotter than the water at the beach and so on. And that is a big part of the reason why sea breezes happen, as you'll see in the 5th module. And as we're about to see, the fact that the desert is so much hotter than the surrounding ocean is a big part of the reason why monsoons happen. So again, actually that's somewhat less superficial as to that is a similarity between sea breezes and monsoons. But they are not exactly the same thing. The monsoon is not just a big sea breeze or something like that. So just to give you a sense of what I'm talking about here, here happens to be a map that I happen to have on my hard drive for a presentation I'm getting ready for in tropical meteorology, where I just happen to have, on this day, the temperatures near the surface of the Earth across the Sahara Desert. And you can see, I mean, 45 to 50 degrees, certainly 37 to 45 degrees Celsius across big chunks of the Sahara Desert. It's hot, okay? Very, very hot conditions there. And when very, very hot ground is touching the atmosphere, there is a process that produces an area of low pressure at the surface. It's called, that area of low pressure is called a heat low. That's a good vocabulary word to know. A heat low is this area of low pressure at the surface that is caused by the fact that the ground is getting so very hot. It is not the same sort of thing as cyclogenesis that produced a mid-latitude cyclone, and this thing doesn't have cold fronts and warm fronts. It doesn't have anything like that. It's just an area of low pressure. The air pressure falls when the air is being heated from below through a fairly complicated process that the lucky folks who take tropical meteorology get to learn more details about how it works. But this idea that you get this heat low at the surface is what I want you to dwell on. So we get this heat low forming when we have a very large expanse of ground that's getting hot, like West Africa. Okay, especially the Sahara Desert. You can see that the coastline where the jungles are and so on in Africa is a whole lot less warm than the central parts of the Sahara are. But the Sahara gets really hot and forms this heat low. The same is going to be true in, say, northern India or the outback of Australia or so on. We have other parts of the world where an interior desert gets so much hotter than the ocean around the desert. But we're just dwelling on West Africa right now. Well, we have this big old area of low pressure at the surface in the tropics. I mean, it's only, what, about 15, 20 degrees north of the equator. We're still pretty close to the equator here. There's not a lot of Coriolis force or anything going on, but we do have then a big pressure gradient force that's just pulling air parcels from outside of the low towards the low. And so we get flow pulling air parcels across the equator onto the continent of Africa and spiraling in towards that area of low pressure, because there's a little bit of Coriolis force involved and so on. But we just get this flow that goes from the ocean to the land because of this area of low pressure we've created over the land in the tropics. Oh, this isn't going to work in the winter. In the wintertime, we got a different phenomenon going on that is more what you expect of the tropics, of setting up these trade winds and so on. But the monsoon flow is really quite interesting, right? It's about this heat low that we formed by this big desert and so on. Monsoons are planetary scale phenomena. The monsoon feature itself is thousands, if not 10,000 kilometers across, you know, like in the case of, say, Southeast Asia or something like that, where it would span enormous areas. The flow is actually perturbed or changed or reversed or whatever you want to say over enormous areas. And they last a really long time. Monsoons last months. Typically about half the year is a monsoon season. And so we were going to call these things planetary scale features in the atmosphere. But they're full of other stuff. The monsoon, the change in the circulation is planetary in scale, but as you see in this satellite animation here, inside of the monsoon circulation, there are all kinds of synoptic scale and mesoscale storm systems. This satellite loop that you're watching right now is false color, and we're not going to get into all the details of how this was made and so on, but I doubt it's any huge surprise to you that what you're seeing here moving across West Africa, those are storm systems, those are clouds and stuff that you're seeing. And you can see that there are all kinds of migratory storm systems moving through West Africa during the monsoon season, and they're smaller than the monsoon. They're either synoptic scale or mesoscale. There's actually something really fascinating going on. See how they're all moving from east to west? But remember, the winds were actually kind of from the southwest. These storm systems are going upwind. How cool is that? Man, West Africa is a great place. No wonder Dr. Shragi gets all excited about it. Now, it occurs to me as I'm giving this presentation that I didn't talk about one detail. I had promised you back in the jet streams section that we would talk about the fact that there was one more jet stream that was related to the monsoon, the tropical easterly jet. Let's not dwell on that too much, okay? There's no wind power connection to the tropical easterly jet, and yeah, that doesn't seem like the most productive use of our time. And so take my tropical meteorology class to learn all about how tropical easterly jet streams, a jet stream out of the east in the tropics and is related to monsoons, how that all works. But we're not going to dwell on that right now at Wind Power. All right, we're done with a huge lecture. Let's go ahead and ask some quick questions. Question 15. Monsoons happen where the winds in the tropics, which are normally blank, reverse and stay that way blank. Are these winds in the tropics normally westerlies or easterlies? And how long do they stay that way? For the rest of the day or for months? Which of those is the right way of describing what happens in a monsoon? Make a choice from your 4 options and get a little feedback before you move on to question 16.